Now that we have the voltage at the primary, we could now also solve for the current at the primary. And using this equation here, we solve for the primary current, the phase primary current, and that will leave us with that the phase primary current is equal to the secondary phase current over, the gain in the phase. If we substitute, we have that the phase current here, we know that this current is in series with this current, so they are the same. And we know that even though this is a line current because it's from here to here, it's also the phase current from here to here. So now that we have the phase current, or we know the value of the phase current, this is all divided by the phase gain. We could substitute those values. Notice again that I'm not using any angle, and it's because the angle at the primary is going to be the same angle as the current in the secondary if I use the phase transformation. Now the gain, as we said before, the gain or the rating, better known as the rating, are given in line to line values. And because we are using the phase transformation, we need those values in phase values. As we said before, the 24,000 volts are phase voltage here in the secondary, because the phase voltage in the secondary is in a delta configuration, and the phase voltage is from A to B. Now here in the secondary, the phase voltage is from A to N, and we are given the 13.2 thousand volts from A to B. So we have to find the value, and that is achieved by dividing those 32,000 by the square root of 3. And now we could just input that in our calculator and find the value of the current at the primary. You should be careful here when entering this value, because sometimes when using the calculator, if it's not entered correctly, you will get a incorrect response. as we said, the angle in the primary is going to be equal to the angle at the secondary as long as it's the phase value. In this case, the phase angle is negative 36.8699. Okay, so we have the voltage at the primary, and now we have the current at the primary. But we want the voltage from the source, the line voltage at the source. And it is interesting to see that the same voltage in this point here is the same voltage at this point here, and that the same point on voltage here at the point V is the same voltage as here in the point V. So the voltage that we said was the voltage, the phase voltage at the transformer, is also the line voltage at the transformer. I mean at the generator. But it's not the same for the current. The current that is in the phase is not the current in this line here, and it's not this current either. This can be easily transformed using the delta, the Y delta circuit analysis transform for a current, and we know that the line current is going to equal the phase current in delta times the square root of 3 minus 30 degrees. The line current in this case is the current from A to N. The phase current is from A to B. 3. So the current flowing through here is going to equal to this current times the square root of 3, and the angle is going to be subtracted. So you have 95.33 times the square root of 3 and negative 36.89 minus 30 degrees. And this is going to be the current at the transformer. I mean at the generator. And there we go.